does know. So if he does that out, so unit is exponential functions. So those are just functions that have your variable x in the exponent rather than like x squared or like 3x or whatever we've had before with like the linear or quadratic functions. So for your exponential functions, your x is always in your exponent. And then like this is our equation for exponential growth. We also have exponential decay, so we'll look at that in just a moment. There's a bunch of different like letters here, but a lot of them mean the same things that they have meant all year. So the y is still your like dependent variable. And we've not called it that in this class, but have you heard of like independent variables and dependent variables like in science? Yeah, I hope y'all talked about that. So like the independent variable is usually like time, so something that will just keep going no matter what. And then maybe your dependent variable is like temperature. So we know that like as time goes throughout the day, what happens to the temperature, especially this time of year? It goes up. And like that kind of depends on the time of day, right? It's warmer at lunchtime than it is right now. Okay, so that's kind of like how you can think about your independent and dependent variable. So like our y value out here is going to depend on whatever the x value is. So a lot of these problems are talking about like putting money in a bank and like the value of something going up or going down. So the value of something, whatever it's worth, is going to depend on like how old it is. So, like the value of a car. If you've got a really old car, is the value of that like really high or kind of low? It would be low. An old car is not worth as much as a new car. So that's kind of like where we're going with some of this stuff. So your y is like your dependent variable. It's usually going to be money or population. Do y'all want to write that in? Money or population. Do you know what I mean by population? So like how many people live in a town, or how many animals are in a population, a group of animals living, I don't know, somewhere. So that y variable is usually like money or a population. And I'm referring to this little formula here. So the A that's right here is always going to be our initial amount, so whatever we start with. Does the word start amount make more sense to us than initial amount? Okay, let's write that. So let's say start amount or starting amount. Thank you. So this number out front is our starting amount. So they'll give you like some, usually it's a big number that we'll put there, and then kind of go from that. The next thing, so if it's growth, we're always going to have 1 plus inside parentheses. And then this R is your growth percent or your growth rate. So I'm going to say growth rate. It's usually, not usually, it's always given to you as a percent. So we're going to take that percent and we need to convert it to a decimal. Do we know how to convert a percent to a decimal? Okay, so what you're going to do is take that percent, whatever it is, and divide it by 100. So we'll write out what that means in context when we go practice some, but that's what we'll do. That's how you convert from a percent to a decimal. Okay, are we all right with all that so far? Okay, and then the last thing, our exponent, is going to be some measure of time. It's our independent variable, and we've already talked about that a little bit today. And again, that's like some measure of time. So they might say like this is the value in years or weeks or days or seconds or minutes, whatever it might be. But it's usually some measure of time. I don't remember to do that. So I'm sorry.
It's okay.
Are we okay with all these things so far? Okay, so that's like our formula for exponential growth. So if it's growth, do you think it's getting bigger or smaller? Bigger, right? Makes sense? So our other one is exponential decay. So do you think it's getting bigger or smaller? Smaller. So the only difference when we write that formula is there's a minus for the rate instead of plus for the rate, okay? Everything else is exactly the same. So what does our y variable still stand for? Say it again. Your dependent variable. And again, we said that was usually like money or population. Okay, so what is that A still going to represent? Your starting amount, good. What is that R going to represent? Last time we called it the growth rate. What do you think we'd call it this time? If we're talking about decay now. Decay rate. And again, that's like the percent that they're going to give you. We need to convert it to a decimal. How did we say that we're going to do that? Good. So that percent, whatever again they give you, over 100. So that probably still sounds a little bit weird right now, but I think when we go practice it, it'll make a little bit more sense. And then the x, our exponent here, is still going to stand for what? Your independent variable, which is usually going to be some form of time for us. Do we have questions on anything so far? Okay, cool. So the first few that we're going to do, I think they're pretty intuitive as far as like what we need to do. So we're just going to jump on in if that's all right with y'all. I'll give you a second to get all that written down, and then we'll go look at the first one. You do have Desmos pulled up, yes? Because again, like everything that we're doing today is in the calculator. So if you type it in the calculator, like I'm asking you to, and do it like I'm asking you to, it's going to be pretty easy. However, if you got your head down and you're sleeping and you're not paying attention and you're being too lazy to type it in the calculator, you're not going to get it. Aiden. So, thank you, friend. Get your computer open. We're on the calculator. All right, so for the first one, can I scooch? Is that okay? Has everybody got this written down? Okay. So it says the value of a computer, a number of years is multiplied by your function right here. And then it says the number of years is represented by x. So what will the computer be worth after 1 year? What do you think we could do? If it says that the number of years is represented by x, they want to know what the value is after 1 year. So what does x equal? 1. So this is just saying if x is 1, what is y? How do you figure that out? Plug it in the calculator. That's how that works. Anytime they say that x equals this, what is y? You just plug it in. So just plug in that value of x wherever you have an x. And that's all we've got to do. So I'm going to write out what we're typing in the calculator here just so that you can see it. So I'm using the function that they gave us, which was 4,000 parentheses 0.72 to the x. But what did we say we're going to put in place of x? 1. Are we ready with that? Yes or maybe? Okay, so type this in exactly like I just wrote it here. Can you do that? Have we typed that in? Yeah? Okay, so what did we get? 2,880. And now we're talking about the value of a computer. So is this money? Right, that's what the value is, right? So I'm going to put a dollar sign in front of that. We don't have any decimals with that, so we don't have to worry about rounding on this one. We'll just put the exact answer that we got. Are we okay so far? Questions on anything right now? Okay, so looking at the next part, it says what will the computer be worth after 5 years? What do you think we need to do now? Plug in 5. Yeah, that's it. That's all we got to do. So we're going to say x equals 5. So if you still have it typed in your calculator, how many of you still have it typed in your calculator? Just change that exponent to a what? A 5. So now this time we've got a lot of decimals. I'm going to write out again what we typed in just so that we have it. 0.72 to the 5 equals. It's talking about money still, correct? How do we normally round money? How many numbers are after the decimal? 2, like cents, right? So like to the 100. So we know it's going to be 773 point. We're looking at the second number after the decimal, and it's a 6. So what's behind that? 7. What is that 7 tell the 6 to do? Go up. So it's going to be 0.97. 773.97. That's our final answer on that one. Are we okay with that? Yeah. Okay, cool. Not too bad yet, right? Okay. So the last part, do you think that this function represents growth or decay? Why do you think it's decay? The values are going down? Yeah. So can we also do something else? Actually, remind me, and we're going to compare the two in just a moment. But are we okay with that being decay right now because the values like went down? Yeah. What did we start at? What was our starting amount for this one? Look at your equation. What do you think it was? So if we look back up here, which letter told us the starting amount? Which is like this up in front of parentheses, right? So what was your starting amount here? 4,000. Okay, so I'm just going to jot that down. Start was 4,000. Are we okay with that? So if we started at 4,000, these went down from 4,000, right? They're both less than 4,000, so that would be a giveaway that it's decay. Are we all right with that? Generally, technology, if I go buy a computer today, next year, is it going to be worth as much money? No, technology always goes down, right? It's like when you go buy the new iPhone, like what phone are they on now? Like the 17, 18, 16? So like is the 12 worth anything anymore? No, because it's old. Does that make sense? So like it's decaying, right? That's the value of that. It's decay. So that's real life stuff, yeah. We're going to come back to that for another thing to look at in just a moment. But let's go to the next one for now. So it says this function gives a country's population, so that's like how many people, in millions, where T is the number of years since January 2000. So according to your function, what was the population of the country in 2004? So we're not just going to plug in 2004 like we did last time. This one's a little bit tricky. What year did we start in? 2000. So then in 2004, how much time has passed? From 2000 to 2004. 4 years, right? So what do you think we need to plug in this time? 4, yeah. Are we okay with that? So if they'd say like this starts in whatever year, you'll have to like subtract the year they're asking about and the year it started in to figure out what your T or your X might be, okay? So this time we're plugging in a 4 for our T, for our exponent. So we're going to have 58.7 parentheses 1.03 to the 4. Before we go type that in, what's your starting amount this time? Good save. What do we start at this time? Yeah, 58.7. So your starting amount is always that number out front, right? I'm just going to jot that down. We started at 58.7. Okay, so we need to go type this in the calculator and see what we get. It doesn't tell us specifically how to round, so let's go to the 10th. How does that sound? Are we okay with that? Going to the 10th. How many numbers after the decimal is that? 1. So if we go look, the first number after the decimal is a what? A 0. What's behind it? What does that 6 tell the 0 to do? Go up. So 66 point what? 1. Good. 66.1. That would be our population. Now it is in millions, so 66.1 million. Are we okay with that? Okay. Questions on anything so far? All right. What did we start at again? 58.7. And when we had like 4 years later, we were at 66.1. So, oh, we're not there yet. I'm going to flip over because I jumped the gun. Is it growth or decay? Growth. How do we know? It's going up. So it's according to the function, is population growing or decaying? I should say growing. But it's growth, and we know that because the population already went up just 10 years later. Are we okay with that? And then I'll go back and answer the second question that I skipped because I got so excited about it being growth. Okay, so back here it says what's predicted for the function for the population in 2016. What are we plugging in for our exponent, our t this time? 16. How do we know that? 16 years after 2000. Are we okay with that? Okay, so in our calculator, we're going to do that 58.7 parentheses 1.03 to the 16 this time. And we'll round to the 10th again if that's okay with y'all. Do we have our answer yet? Yeah? Okay, so we're rounding to the 10th. That's the first number after the decimal. So what is it? A 1. What's behind it? What does that tell this 1 to do? Go up. So 94 point what? 2. Fabulous. 94.2. Are you okay with all that? Okay, so on the back side, we already answered the question that said that this one was growth. The last one that we did was decay. So I want you to take a second, look at the functions. So the function that they gave us, how could we tell by just looking at the function without plugging anything in, how could we tell if it's growth or decay? Look at them and see if you can find the difference. What you mean the decimal? Where are you looking? Be more specific. You're on the right track. So right after the starting amount, inside the, what are these thingies called? Inside the parentheses, we've got 0.72 here, or like 0.72. They just didn't write the 0. On this one, we've got 1.03. What's the difference between those two? One is bigger than 1. One is smaller than 1. Is that okay? So I'm going to jot down a note here. This one is less than 1. So if the parentheses are less than 1, it's decay. Are we okay with that? So the number inside parentheses, if it's less than 1, it's going to be decay. Do we have that written down? And I'm going to show you why in just a second. Can I show you why? Go back to our formula. How do we get that number inside parentheses? Because we're going to go do this in a second. What do they do to get that number? 1 minus something. So if you have 1 and you subtract something, is it going to be more than 1 or less than 1 now? Less, right? That's just like common sense, right? So then if we go look at the second one, which we said was growth, this number, is that bigger than 1 or smaller than 1? 1.03. That's bigger than 1, right? This number is bigger than 1. I'll write that really small right there so we don't get confused. So if the number inside parentheses is bigger than 1, that's going to be growth. So I'm going to flip over to the back where we wrote that again. So when we said it was growing, years ago, Andy invested $5,000 in an account. Here is your equation. It describes the balance in the account where time is t in years. Andy made no additional deposits and no withdrawals. So first off, what did we start with? 5,000. So we started at 5,000. It's just good things to know and go ahead and start recognizing. 1, 2, 3. Is this one growth or decay? We can already tell how. Inside parentheses, that is greater than 1. So that's part C. Does it represent growth or decay? Growth. And how did we know that? The number inside parentheses was bigger than 1. Are we okay with all that? Okay. So let's go back to the first question, part A. It says, how much is in the account now? Well, when did we make the account? When did Andy set all this up? 3 years ago. So what do you think our exponent, our x, our t needs to be this time? 3. So t is going to be 3. So I'm going to use our function that it gave us, which had the 5,000 out front that we started with. Then 1.05 inside parentheses. And we said our exponent this time is going to be 3. And I'm just writing out what we're putting in the calculator so that when you look back at your notes later to help you do more examples, you'll know what we did. So we'll go type that in exactly like we wrote it on our paper. Now, we're talking about what in this problem? I think somebody said it. He invested, what does this mean? Money. So what are we talking about? Money. So how should you round the answer for money? How many decimals should we have? 2, because that's how money works, right? It's always like got 2 numbers after the decimal. So for our answer here, we want to round to the 100th. That's what that's called, right? Rounding 2 numbers after the decimal. So the second number after the decimal is the 2. What's behind that 2? A 5. So what does that 5 tell us to do? Go up. So 5788.13. Okay. Good. Are we okay with all that? Okay, so again, if you are not typing this in the calculator, every time I'm typing it in the calculator, you are probably not going to get it. And whose fault is that going to be? So if you were just doing this with me, it's really not too bad. All right, the next part says how much will be in the account 10 years after it was invested. So what does it want us to do? Plug in 10. So t is 10 now. So we still have our same function. 5,000 with the 1.05 to the 10th. So changing that exponent to a 10, we're still going to round to the hundredths because we're still talking about money. Do we have an answer? So this time we've got this one. We're going to the hundredth. That's the second number after the decimal, so it's a 7. What's behind that 7? What does the 3 tell the 7 to do? Stay the same. So we're going to have 8144 point what? 47. Yep. Are we okay with that? Questions on anything we've done so far? Okay. So now, instead of them giving us the equation, we're going to learn how to write the equation. Is that okay? So we have to decide, I'm going to flip back to the front, a couple things. What is our starting amount? We got to know what A is. we've got to know the rate, the percent that they're giving us, and we have to know if it's growth or decay, so we know if we're going to do plus or minus. Are you okay with that? All right, so the first example that we have, all we're doing is just writing the equation. We're not solving anything on these. It says an element with a mass of 490 grams decays by 28.6% per minute. So I'm going to start with the y equals, and then we have that A out front. I'm referencing back to those formulas we had on the front of the page. Should I write that over here? Would that be helpful? So it's y equals A, parentheses, 1, either plus or minus. I'm going to write them both right there. Do y'all remember that little symbol that we've kind of seen before? We talked about that a little bit last unit, to the x. So that A is our starting amount, our initial amount. So what do we start at this time? 490. Good. Are we okay with that? I hate to say it's common sense, but like I kind of feel like it's common sense, right? Okay, inside parentheses, we're going to have a 1, and then we'll put a plus if it's growth, we'll put a minus if it's decay. So which one is this one? Decay. What told us it was decay? Literally says decay. Are we all right with that? So we're going to say 1 minus. For the R, we said we would take the percent that they gave us and put it over 100. So what's the percent they gave you? So 28.6 over 100. So that's kind of like a little complex fraction right there. Are we okay with that? Yeah. And then x is still going to be in our exponent up here because we're just writing the equation. So we're not trying to like figure out an answer yet. We're just trying to find an equation to model the situation. Are we okay with all of this so far? Yes, so maybe. Okay, so I'm going to flip back for just a second. And the problems that we've done so far, did they have like plus and minus and fractions and stuff going on? They went ahead and simplified that. So like on your exam, if you're asked to write an equation for something, they're probably going to go ahead and simplify this again. So what I want you to do next is just type in this stuff that's inside the parentheses. Can we do that? So I'm going to type in 1 minus 28.6 over 100. Now, if we were asked to like write the equation and figure out something else, which we're going to go do later, then we can type it in all messy and it doesn't matter. But if you have to find an equation to match and it's like multiple choice, they're probably going to go ahead and do that subtraction. So we typed in the stuff inside the calculator. This is what we got. Are we okay with that? So that's exactly what we need to put inside our parentheses here too. So we still have that starting amount, that 490 out front. But inside the parentheses, all of this stuff simplified to that 0.714 that we got in the calculator. Are we okay with that? Yeah, and then we would still have like x in your exponent. So again, if this is like a multiple choice situation on your exam or your test or whatever you might have to do, they are going to go ahead and do this. So this is how you set it up, but simplify it to this. Are we okay with that? Yeah, do you have questions on anything so far? Okay, a lot of y'all are sleeping. I need you to wake up. Wake up, wake up, wake up. All right, the next one says $2,200 is placed in an account with an initial interest rate of 7.25%. So let's go ahead and start with our y equals. That's always going to go in the front for our equations. Then we need that A value, the starting amount. So how much did we start with? What was it? 2,200. Inside parentheses, we're going to do 1 and then either plus or minus, just depending on if it's growth or decay. So what do we think this time? If we're putting money in an account, do you think we put it there so that we'll lose money, or do we put it so it'll earn interest, like a savings account? So it'll like earn money, right? So do you think it's going to be growth or decay? Growth. So do we want to do plus or minus? Awesome. And then we have to do our rate, which is the percent they gave us over 100. So what's the percent that they gave us this time? So 7.25 over 100. I'm going to close those parentheses and put it to the x. Now we want to clean that up just a little bit. So we'll go type in the stuff that we put inside parentheses. So 1 plus that 7.25 over 100. Jaden, did you figure out how to do that on that calculator? Okay. And we're going to put exactly what it says. We're not going to worry about rounding anything. So the number up front, the a value, is still going to be what? 2,200. Inside parentheses, when we typed all of this stuff in the calculator and cleaned it up, what do we get? 1.0725. And again, we're just going to put exactly what we get. Don't worry about rounding anything. Are we okay with all that? Okay. And what do we still need in our exponent? X. Good. Done. Because again, we're just writing the equation to like model any situation, so we don't know what X is yet. Are we okay there? Questions on anything? Okay. Looking at the next one, a new car is purchased for $22,300. The value of the car depreciates at 10.5% per year. So let's start with our y equals, and then we'll put that a value, the starting amount. What's the starting amount this time? $22,300. I usually just say 22300. I hate reading numbers. I know I should love to read numbers as a math person, but it is not my jam. Are we okay with that? All right. Inside parentheses, we're going to have 1, and then either plus or minus depending on if it's growth or decay. So what do we think this time? Why do we think it's decay or minus? Depreciates. I don't know if you've heard that word before, but that's what that word tells us. It tells us that it's decay, so the value is going down. Y'all haven't had to buy a car yet because we don't drive yet, but when you go buy a car, so like you go buy a car, a brand new car, and you drive it off the lot, do you know what happens to the value immediately? Tanks. It like cuts in half because now it's used, even though it's been used for like a mile. So that's like always going to be depreciating, guys. So the value of a car is always going to go down after time. So we've got 1 minus, then we need to do our rate, that R value here. So that's our percent over 100. So what was the percent they gave us? 10.25 over 100 to the X. I'm going to go put a note of that up here. This R is always going to be the percent over 100. All right, so we're going to clean that up just like we have on the last couple ones. So we still have the y equals. We still have that big number out front we started at. Inside parentheses, when we clean that up, does anybody have it yet? .8975, is that what y'all said? Okay. I'm telling y'all I can't hear half of what you're saying. So are we okay with that one? Yes, sir, maybe? So again, we're just like typing that in the calculator, whatever we had in parentheses the first time, and we're just cleaning it up. We still okay? So the next one, number 4, a town has a population of 9,000 and grows at 3% every year. So we're still going to have that y equals out front. And then what's our A, our starting amount this time? 9,000, good. Inside parentheses, we're either going to do 1 plus or 1 minus, depending on if it's growth or decay. So what are we thinking for this one? Why is it plus? It literally says gross. So plus. Then for our R, we're going to do the percent they gave us over 100. So what percent did they give us? 3. So we'll say 3 over 100 to the X. We want to clean that up just like we have been. So we'll still have the y equals and then the 9,000 out front. But when we clean this up, we do 1 plus 3 over 100. What do we get? And what's your exponent? Still x. Good. Are we still feeling all right with these? Yeah? Okay. So the next ones, we've got to write the equation and evaluate them. So they're going to like give us the situation. So we'll write the equation like we have been. And then we're going to go plug something in for x as well. Okay, so we're kind of putting the two skills together now. Are we ready for that? Okay, so the first one, it says $1,600 is placed in an account with annual interest rate of 5.25%. How much will be in the account after 25 years to the nearest cent? So let's start by writing our equation. So we're going to have y equals. And then we need that a value, our starting amount. What's the starting amount this time? I'm about to put popsicle sticks because y'all are all here and we all know what's going on. Bree, what's our starting amount? Awesome, 1,600. And then we'll have parentheses of 1. And then we're either going to do plus or minus, just depending on if it's growth or decay. Do we have any thoughts about which one it might be this time? So we're putting money in an account. Do you put money in the bank to earn money or to lose money? To earn money. That's why you it's like an investment, right? So you put money in the bank to earn money. So if you're ever talking about putting money in the bank and getting interest, that's going to be growth every time. Are we okay with that? So since it's growth, what do we need to put? 1 plus. Then for that R value, that rate, we're going to do the percent they gave us over 100. So Miguel, what was the percent they gave us? Good. 5.25 over 100. I'm going to close those parentheses. And this time, they're asking us to go ahead and evaluate that. So can we do two things at once? Can we go ahead and put in whatever exponent we need? So let's keep reading. It says, how much will be the account after 25 years? So what do you think your exponent needs to be? 25. Now, because we just have to figure this out, they don't really care what the equation is, we can type this in exactly as we wrote it. We don't need to worry about cleaning it up. We can just type it in, and then we're going to round it to the nearest cent. Can we do that? Okay. Now, Jaden, that might be a little bit different on your calculator, but I think you can figure it out. Can you? Yeah, if not, let me know. You got it figured out. Awesome. Fabulous. All right. Do we have an answer? Okay. So I'm going to pull it up over here. It said to round to the nearest cent. So again, we know we're talking about money. So the nearest cent is how many numbers after the decimal? 2. So we're looking at this 6. What's behind that 6? A 2, which tells this 6 to do what? Stay the same. So our answer is going to be 5750. 0.06. And that's because this 2 told the 6 to stay the same. Are we okay with that? Questions on anything so far? No. Risa, you good? Okay. All right. Number 2, the next one. It says a town has a population of this much and grows at 2.5% every year. What will be the population after 5 years to the nearest whole number? So we can start with our y equals. And then we need to put that a value, so our starting amount. Natalie, what do we start with this time? Good, 13,000. And then we're going to have parentheses and a 1. We have to decide if it's going to be plus or minus, so is it growth or decay? How do we know? It says growth. So if it's growth, what are we doing? For growth, what are we doing? Plus or minus? Plus. So then for that R, we need our percent that they gave us, and we'll put it over 100. So Jacob, what was our percent this time? 2.5. Good. And again, that's over 100. So whatever percent they give you, over 100. And then our X is going to be whatever time they're asking us about. So what does our X need to be this time, Caleb? Yeah, 5, because it just wants to know what it is after 5 years. So we'll put a 5 in for our exponent. This time they want us to round to the nearest whole number. That means no decimals at all, yeah? Okay, so go ahead and type that in, and we're going to round it to a whole number. Do we have an answer? Did we get it typed in? Okay. So that's what I got. If we round that to a whole number, that means no decimals. So we're going to chop it like the 8 here. What's behind that 8 though? What does that 0.3 tell this 8 to do? Stay the same. So our answer is going to be what? Love that. Amazing. Good? Alrighty. The next one is a new car is purchased for this much money. The value of the car depreciates at 12% per year. What will be the value of the car to the nearest cent after 13 years? So we're going to start with our y equals as always. And then we need that a value, the starting amount. Landon, what's the starting amount this time?
24,800.
Yeah, that big number. So the 24800, right? Yeah. And then in parentheses, we're going to put a 1, and then either plus or minus, just depending on if it's growth or decay. So Xavier, what do you think it is this time? Growth or decay?
Decay.
How do you know?
Because it depreciates.
Depreciates. So y'all, are we going to put plus or minus? Minus. Great. And then for the R, we've got to do our percent over 100. So Gracie, what was the percent? 12. So we'll say 12 over 100. Then we can close those parentheses, and we've got to figure out what our exponent is. What do they want us to plug in this time, Coraline? Yes, ma'am. So our exponent's going to be 13. It told us to round to the nearest cent again. So what does that mean? How many numbers after the decimal? 2. Like money usually does, right? Is that okay? All right, so let's type it in, and we'll round it to the nearest hundredth. That's called if you're going to use the fancy math words. So 2 numbers after the decimal. Have we gotten to type it in? Yeah? Okay, so I think y'all are a little bit faster than I am, but that's okay. So we'll have 4706 point. We're rounding to the hundredth, the cent. So that means 2 numbers after the decimal. So we're looking at the 0. What's behind it? A 7. What's that 7 tell the 0 to do? Go up. So point what? 8. Sorry, I didn't get the 8 in there yet. Are we okay with that? Yeah, cool. And this was money, so I'll put a dollar sign out front. Okay, last one. An element with a mass of 670 grams decays at 27.3% per minute. How much of the element is remaining after 9 minutes to the nearest tenth of a gram? So we're going to start with that y equals, as always. And then we need the a value, our starting amount. Aiden, what was the starting amount this time? Good job. 670. And then we'll have parentheses. Jayla, what goes next inside the parentheses before anything else? A 1. Good, good. We always got to get that 1 in there, okay? People tend to start forgetting that, but don't forget the 1. And then we'll either do plus or minus, just depending on if it's growth or decay. Kaylee, what do you think it is this time? Growth or decay? And how do you know that? It says decay. So what are we going to put? Plus or minus, y'all? Minus. Good. Then to get that R, we've got to do our percent over 100. So Jaden, what was the percent? 27.3. Awesome. Over 100. The last thing we need is our exponent. So Roxana, what's our exponent? Not 10. 9. Yeah, so remember our exponent, that x is always some measure of time, right? So I would look for a time in your problem, like seconds, minutes, hours, weeks, days, months, years, something like that. This one says minutes, so that 9 minutes is what we want our exponent to be. Are you okay with that? All right, so we'll get our answer here, and they want us to round it to the 10th. So that means one number after the decimal. Have y'all already typed it in? Y'all are so fast. Okay, so I think I'm doing it right. If we're rounding to the 10th, again, that's one number after the decimal. Is this what y'all have? Yeah? Okay. I was like, did I do goof? Okay, so the first number after the decimal is what?
0.
What's behind that 0?
0.
Another 0. So what does that 0 tell this 0 to do? Stay the same. So what's our answer going to be? 38. You can just put 38. I'm going to write the point 0 just so that we know like that's what a tenth means. But 38 or 38.0 should be fine. And that's all we got. How are we feeling? Are we okay? All right.